Hey guys, so today we're going to go over complex numbers, and a complex number is just a real number, which we'll call A, plus or minus an imaginary number, which we'll call B. And it's noted that it's an imaginary number because it has I with it. So A and B are just numbers. So when you're dealing with a complex number, just one thing to remember, I squared is -1. And the reason for that is because I, meaning an imaginary number, represents the square root of -1. So because you can never have a negative inside of a square root, it's imaginary. So let's say I were to square this I. Whatever I do to one side, I do to the other. So from here, I squared equals squares and square roots on the right get rid of each other, leaving you with -1. So I squared equals -1. So that's the proof behind it. And then just something else to prep when dealing with complex numbers is you want a list of your perfect square roots. So remember 1 times 1 is 1, so the square root of 1 is 1. 2 times 2 is 4, so the square root of 4 is 2. 3 times 3 is 9, so the square root of 9 is 3. 4 times 4 is 16, the square root of 16 is 4. 5 times 5 is 25, the square root of 25 is 5. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 9 times 9 is 81, so the square root of 81 is 9. 10 times 10 is 100. 11 times 11 would be 121. I'm going to stop soon, I promise. 12 times 12 is 144. And 13 times 13 is 169. So just a couple of perfect square roots for us to work with. It does help when dealing with the problem. So for instance, if you look at number 1, we're trying to simplify the square root of -48. So once you have a negative inside of the square root, you're going to rewrite that as I, meaning that represents the square root that's negative inside of it. So we took that out, which means we're left with just the square root of 48. So to simplify the square root of 48, what you're going to do is you're going to look for the largest perfect square root that 48 can be divided by. So if I look, 48, can it be divided by, I'm going to go to the closest number that's less than 48. 36, 48 cannot be divided by 36 perfectly. 25, no. 16, yes. So if I divide 48 by 16, I'm going to get 3. So here I'm going to write the square root of 16, and here I'm going to write 3, because 16 times 3 still gives me 48. And then I'm going to simplify. So the square root of 16 is 4. Bring down that square root of 3. That's a decimal, 1.7, so you can't actually do anything with it. We're only square rooting the perfect square root from this list. And don't forget this I. That comes down as well. I always put it between the whole number and the square root. You may see it put in a different manner when it comes to your multiple choice answers, but that's pretty much it. Now, let's say that they ask you to simplify I to the 21st power. What I want you to do when it comes to simplifying this is I want you to take the closest even number that's less than 21, which is 20. That leaves you with one I left over, so I to the first power. So why am I doing this? Well, let's say, remember I squared equals -1, right? So I'm going to rewrite this as I to the 10th power, and I'm going to square it. So remember, when you have a power to a power, module 1.01, 1.02, you multiply. So this would be the same thing as I to the 20th power. And I'm going to rewrite that. And I could switch it around too. 2 times 10 is also 20. Why am I doing that? Because I know what I squared is. I squared is -1. What's -1 to the 10th power? Well, anything that's negative that has an even power is going to come out positive. So that's +1. And then this I that I've never used at all, I'm going to bring it down. So this ends up 1I to the first power just being I as your answer. Okay, So we're moving on to the next problem, which is kind of like number 1. The 6 is just the real number. Remember, a complex number is a real number plus or minus an imaginary. So all I'm going to do is I'm going to keep bringing down the 6 plus square root of negative 40. This is the imaginary number I need to simplify. I know it's imaginary because there's a negative in the square root, so I'm going to first take the negative out by writing I and bring down the rest. And again, we're just going to bring this down. Our work is in simplifying the square root of 40, so we're going to look for the largest perfect square root that 40 can be divided by. So what you're going to do is you're going to go to the closest square root less than 40, which is 36. Again, 40 and 36 do not go into each other perfectly. 40 divided by 25, that doesn't work either. By 9 doesn't go perfectly into each other, but 40 divided by 4 does. So I'm going to bring this down. The square root of 40 can be divided by the perfect square root of 4, which would leave me with 10. So square root of 4 is 2. Bring down the square root of 10. And everything else that I haven't used, I'm going to bring down. So the I will come down, and 6 plus will come down. So this is my real plus or minus my imaginary number, and it's simplified. Now, one thing I do want to note, if ever you're simplifying, and let's say that this square root can still be divided by one of these perfect square roots, it means here you haven't chosen the largest perfect square root that the number can be divided by. So make sure that you always start with the number closest to your given square root, but less than it. All right, guys, hope this helps.